Alright, इसमें क्या कह रहा है? You remember the concepts that we discussed the other day, right?
Yeah.
अभी क्या है, there's a loop, radius is r, magnetic field is b perpendicular. This time r is increasing. So tell me, when only when the flux changes do we get a current or an EMF, right?
Yeah.
And flux can change in three ways, like we discussed the other day. Either you change b, or you change a, or you change the angle between them, right?
Yeah.
In this particular case, what is changing? Can you tell me?
A.
Of course, a is changing, isn't it? So
Yeah.
that's all we have to do. We just have to find the flux, and then take our differentiation, because we know that EMF generated is minus d phi by dt, isn't it?
Yeah.
Let's try and do that. चलिए कोशिश करते हैं. So radius as a function of time is given. So can we find area as a function of time? Isn't it pi r square?
Pi square. Yeah.
Yeah, so let's do that. Pi times r naught plus t whole square. That's my area as a function of time. This is r as a function of time. So when I square this, I'm actually squaring this, isn't it?
So first of all, as a function of time means what? Like, is it already differentiated for me, or am I supposed to do it?
No, no, no. As a function of time means, like, with time, what is the radius? Like at time t is equal to 0, the radius is r naught. This is the radius. At time t is equal to 1 second, the radius has increased by 1 meter. So it has become r naught plus 1 after 1 second. After 2 seconds, the radius has become this much. So with time, it's changing. Okay. A
That's all
normal,
it means.
a normal function of time, like anything, when we say displacement as a function of time is equal to 4t square minus 3t, for example, what does that mean? Which means you put different values of t and you obtain the different values of displacement, isn't it? Or the position,
Yeah.
call it as xt. So you get different positions with function of time, isn't it?
Yeah.
That's
Basically
all.
varies with numbers.
Varies with time in a way. Yes, you can say so. It varies with time in that way, right? So once you have that variation, can you not calculate the area as a function of time now? So
यही
you
हो
can
गया ना
calculate. So you can calculate the flux as a function of time. It's b dot a. Now area vector and magnetic field, since it is perpendicular to the plane, which means they're in the same direction. The magnetic field and the area vector are in the same direction.
Yeah.
So I can straight away say ba cos theta, which means just b into a, which is b into pi into r naught plus t whole square, isn't it?
Yeah.
This is my flux. Now to get the EMF, all you have to do is differentiate this. It's very easy. Tell me. Only this is dependent on time, so I'll take 2 outside, b omega, b pi, r naught plus t, and then you move inside and differentiate this. So r naught is a constant and t, differentiation of t is just 1. So that's about it. That's your EMF. Which one is matching? Uh, ah, so of course the answer is same in most of them, like you can see in this one and this one. So either of these two will be the correct answer. Now let's check the direction. How do you check the direction? We did not use a negative sign here. Negative sign helps us understand the direction, or in simple terms, can we not use Lenz's law?
Yeah.
If the area is increasing, don't you agree that the flux would be increasing?
Yeah.
I want to decrease the flux. I don't like it, right? It's perpendicular to
Mm.
the plane of the ring. So imagine it like this. If this is the ring and I'm increasing the radius in this manner, the magnetic field is, let's say, in the upper direction. Depends on which direction it is. In this question, it's just saying it is perpendicular to the plane of the ring. It's upwards, downwards, that I don't know. Let's say it's upwards right now, and the area is increasing, so the flux is increasing. So in which
Yeah.
direction should the current be? Shouldn't it be clockwise? So as to decrease the flux?
Yeah.
If you consider B in the upward direction, if the B is in the downward direction, then what would have happened? It would have been in the
Anti-clock.
anti-clockwise. So it depends on the frame of reference in reality. Now, from which reference have they asked this question? That depends on them. But I hope you're getting the hang of it.
तो फिर
But
मैं क्या लिखूँ आंसर में?
कुछ भी लिख सकते हो दोनों में, to be absolutely certain. But आपको वो क्वेश्चन पे देखो, कहीं पे आपको क्लियर नहीं कहा कि उन्होंने कि भाई whether they are talking upward direction magnetic field or downward direction. हाँ, they are saying perpendicular the plane of the ring. ना perpendicular ऊपर भी हो सकता है भाई, नीचे भी हो सकता है ना. So
And
that's
what
the
about the minus sign?
this minus is irrelevant now. No, this minus only helped us to understand that whatever answer you're getting, it's trying to oppose the flux. उसी को फैंसी वे कहने का तरीका है नेगेटिव साइन. जब ईएमएफ की वैल्यू निकालते हैं तो उसका कोई अहमियत नहीं रह जाता है, लाइक वी डिस्कस द अदर डे. वी टेक द मॉड ऑफ इट इन रियलिटी. We find the
Okay.
EMF then we try to find the direction using Lenz's law. That's our goal. Okay, so we never
Okay.
use negative sign in the formulation of it. When we are trying to find the EMF, we don't use a negative sign. We just find out the magnitude, and then we use Lenz's law, which states that the current will be induced in such a manner so as to try to oppose the change which is causing it, isn't it?
Yeah.
बस ऐसे याद रख ले. देखो, क्वेश्चन को समझना इंपॉर्टेंट है. इट्स नॉट इंपॉर्टेंट कि भाई इन दोनों में से कौन सा सही होगा. दोनों ही सही हो सकते हैं, डिपेंड्स ऑन द पर्सपेक्टिव. ओके,
Yeah.
ठीक है. सो दिस इज